Okay guys, today we are going to differentiate using the first principle, right? So I've chosen some questions that you might not have seen it from anywhere, right? But they are under your standard, they can always come, right? So let's look at these questions. They look a bit challenging, but after this lesson you will realize that they are not challenging at all, right? Okay, so the first question says differentiate, determine the derivative of f using the first principle, right? Okay, so f of x is equals to 2 minus 5x squared, right? So that is a usual one, right? So we know that our f prime of x will be what? We know that our f prime of x using the first principle is going to be lim h approaches 0, and then we've got f of x plus h minus f of x, and remember you always find this formula in your formula sheet, right? So that is our formula, right? And then what does that mean? This function notation only tells us that we need to substitute our x with x plus h, and then on the other we're just going to put f of x, right? So it's going to be what? Okay, it's going to be equals to our lim, our h is approaching 0, and then which means that I'll write 2 minus 5, and then I will have my x plus h squared, right? And then minus the f of x, I'll put it into the brackets so that my brackets will multiply the whole function of f of x, right? So it's going to be 5x squared, right? So that is my equation all over h, right? All over h. So after this, now all I need to do is to simplify, and then remember x plus h. Every time when I put x plus h squared, I know that it's going to be what? I know that's going to be x plus h and x plus h, right? So simplification of this one, the perfect square, I know that's going to be x squared plus hx plus hx plus h squared, right? And then the middle term is a like term, so I've got x squared plus 2hx plus h squared. Every time I see this, I'm just going to substitute with this, right? I'm doing it for the last time, right? Because I know that I'm going to come across this in so many times, right? So I'll just do it here. So every time I see this one, I'm just going to substitute it with this one, right? So I won't be doing that again, so that our video won't take as too much time, and that we don't need, right? Okay, so then h approaches 0, and then when I simplify, this one's going to be 2 minus 5 into x squared plus 2hx plus h squared, and then minus 2 plus 5x squared, then all over h, right? And then the next step will be to do what? The next step will be to take out to simplify, right? So it's going to be lim, h is approaching 0, and then what do we have here? We've got 2 minus 5x squared minus 10hx minus 5h squared, and then minus 2 plus 5x squared all over h, right? And then after here, now we can add the like terms, right? So where are my like terms? My like terms are here, right? My like terms is this one and this one, right? So the like terms, the other is positive, the other is negative, and they are the same, which means they are going to give me 0, and also positive 2 and negative 2, they are also going to give me 0, right? So I won't have them in the next step, right? So the next step will be lim h approaches 0, right? So I'm left with negative 10 hx minus 5h squared all over h, right? So now I see that I've got the like terms on top. I've got the common factor on top, so I'm going to factor it out, right? Then h approaches 0, right? And then it's going to be h into 10x into 10x minus 5h, right, all over h, and then this h and this h will cancel out, left with, this was negative, remember, negative 10x minus 5 each over 1. So I'm not going to write the over 1. Now my h can approach 0, so it's going to be what? It's going to be negative 10x. So that is my f prime of x. My f prime of x is going to be that one, right? So that is going to be our 5 marks, right? That I'm expecting everyone to get, right? More especially the learner on my online class, they will all get this one, right? They will all get this one. So you should make a right choice and join my online classes, right? Okay, but by the way, let's go to the next question, right? Let's go to the next question. So I'll just keep on posting the same thing so that we can see our question, right? Okay, so the second question, it says what? It says determine the derivative of f using the first principle. Okay, they're saying given that, we're going to number 2, remember, not number 1. We're going to number 2. Number 2, we are given that f of x is equals to x squared plus 2x, right? So this one is also the same as the previous one, right? So we know that f prime of x equals to what? Equals to lim h approaches 0, and then we're going to have our f of x plus h minus f of x, and then all over h, right? Remember, we don't have a mark for a formula in mathematics, but we write a formula so that we don't make mistakes, right? Because if we don't write a formula, and then it means that we are going to make a lot of mistakes, right? Okay, so it's going to be x squared, it's going to be x squared, it's going to be x plus h squared plus 2x, and then it's x plus h, right? It's x plus h, and then minus f of x, which is going to be x squared plus 2x, yes, and then all over h, right? And then the next step is going to be what? The next step is going to be lim h is still approaching 0, and then here I told you that we're going to come across this one so many times in a way that we have to understand that's going to be x squared plus 2hx, and then plus h squared, and then plus 2x plus 2h, and then we've got a minus x squared minus 2x all over h, right? And then again we are going to check our like terms, right? So our like terms is going to be this one and this one, so they're going to be a 0, right? And also this one and this one, so they are also going to be a 0. So I will be left with what? I will be left with lim h approaches 0, and then I've got 2hx over 2hx plus over 2hx plus h squared, and then plus 2h all over h. So again, I can see that I've got a like term. So there's a trend, guys. Every time when we're doing a normal question like this one, everything that's without h should be gone, right? If you see something not going out, not someone, but something not going out, it means that you have made a mistake somewhere and you need to rectify it, right? Okay, so it's going to be lim our h is still approaching 0, and then we can factor out h, and then we've got 2x plus h plus 2 all over h, right? So after here, all the h and the h will cancel out, so we'll have lim, and then our h still approaching 0, and then we're left with 2x plus h plus 2, right? And then when our h approaches 0 is going to be 2x plus 0 plus 2, right? So we won't write the 0, right? So this is our f prime of x, right? So remember to write your f prime of x here all the way, right? So that is our f prime of x, right? So I believe that you're going to get this one correct, right? You're going to get this one correct. I hate these things here. I hate these things. I don't know what are they doing here. Dismiss. Okay, so here also dismiss. Okay, I can just dismiss this one. It's fine. Okay, I didn't know that that I can just dismiss and then they will be gone. Okay, so there is our answer, right? Okay, so let's just go to number 3. Number 3, I will repose the question again. I will repose the question again so that we can clearly see our things, right? I will repose the questions again. So the question is saying what? Saying given that f of x is 2 over x, determine f prime of x from the first principle, right? Okay, so to determine this one, obviously I know that I have, when they say first principle, I'm going to use the first principle, which is f of x, f prime of x is equal to lim h approaches 0, and then this one is going to be f of x plus h minus f of x all over h, right? So that is my equation, right? So that is my equation. I don't know how am I going to do this one to ignore every time. Okay, so now what do I have? I know that my x is what? My f of x is negative 2 over x squared, right? So it's going to be lim h approaches 0, and then I will have my negative 2 over x plus h minus negative 2 minus negative 2. So it's going to be minus negative 2 over h, right? Over x. Sorry, it's negative 2 over x all over h, right? So because that's one, and then the negative and negative will end up cancelling there. So I will have what? I will have lim h approaches 0, and then I will have what? I will have negative 2 over x plus h, and then this one will be plus negative and negative, right? 2 over x all over h, right? And then now it's going to be what? Now it's going to be lim. I'm going to add the fraction on top and see what do I get, right? So adding a fraction, remember if I've got 1 over 3 plus 2 over 5, what do I do? Obviously I will multiply the denominator because they are prime, they are both prime numbers, right? It's going to be 3 multiplied by 5, which is going to be 15, right? So I can just write my 15 there. Over, I will divide this one, and then I will have 1 multiplied by 5, and then on the other side I will have 2 multiplied by 3, right? So that's what I'm going to do even here, right? That is what you do when you've got a fraction, right? I'm going to do the same thing here. So it's going to be what? It's going to be negative 2, okay. So let me write my LCD first. My LCD is going to be x plus h, and then x, and then on top here I will divide x plus h by x, and then I will have negative 2 multiplied by x, and then I'll have a plus 2 into, I divide x and x, so I'll have with x plus h there, right? And then remember, it's still all over h, right? So that I don't mix up my things, I can put the brackets there, just so that I know that, okay, there's a fraction on top divided by x, right? Okay, so after that I'm going to do what? After that I'm going to do this one's going to be lim h approaches 0, and then what am I going to have here? I'm going to have what on top? I'm going to have negative 2x plus 2x plus 2h, and then all over the denominator is going to be x squared plus hx, and then all over h, right? Remember this one is one thing, right? And then now what do I have? Lim h approaches 0, and then what's inside there is going to be negative 2x by plus 2x is going to be 0. They are like terms, right? They're going to give me a 0, so I will be left with 2h over x squared plus hx. This inside the brackets, remember it's over h, right? And then now what do I do? Remember, it's difficult to deal with a division, so I know that this denominator h can be written as h over 1, right? So the denominator as h can be written as h over 1, right? So changing the division line, this division line to be multiplication, it will change the numerator to be the denominator, so it's going to be lim h approaches 0, and then what am I going to have? I'm going to have 2h over x squared plus hx multiplied by 1 over h, right? So there it is, and then this h and this h can cancel, right? Because the other is on the denominator, the other is on the numerator, and then we are multiplying, right? So it's going to be what? It's going to be 2 over, remember it's still lim, right? Still lim, still have lim, h approaching 0, and then now I've got 2 over x squared plus hx, right? So that's what I have now. And then now if I have to add this one, my h, if my h approaches 0, remember this one will only be 0, but it will never affect the x, right? So that's going to be my answer. My answer is going to be lim, and then h approaches 0, and then this one is going to be, oh sorry, my h is approaching 0, then my f prime of x is going to be what? My f prime of x is going to be 2 over x squared. So that is my derivative, right? That is my derivative. Remember the equation was 2 over negative 2 over x squared. Negative 2 over x squared. Remember this can be written as what? This can be written as negative 2 x to the power of negative 2, right? It can be written like this, x to the power of negative 2. So why am I getting a 2 there? Oh, no, it was x to the power of 1, not to the power of 2. So I was amazed, where am I getting the 2 there? So it was like this. So this one can also be written as negative 2 x to the power of negative 1, right? So if you differentiate this one, negative 2 x to the power of negative 1, obviously if this is f of x, the f prime of x will be what? The f prime of x will multiply the exponent with this one, so it's going to be negative 1 multiplied by 2, it's going to be positive 2, and then x, I'll subtract 1 to the negative 1, so it's going to be to the power of negative 2, right? So if I'm writing this with a positive exponent, obviously it's going to be 2 over x squared, so it means that my derivative is correct, right? It means that my derivative is correct. So now let's go to the next question. Quickly. I don't want this video to be long. I want it to be normal, right? I just want it to be short. So what's going on here? Okay, there it is. It allowed me. I don't know why it was running up and down. So there it is now. So let's quickly go to number 4, right? Let's quickly go to number 4, where we've got the equation. So they want us to do a first principle again. So this one's going to be remember our first principle says f prime of x. F prime of x is equals to lim, and then h approaches 0, and then remember it's going to be f of x plus h minus f of x, right, all over h, right? So after this one is going to be lim, h approaches 0, and then what is f of x plus h? Remember, everywhere where I see, remember it was square root of x, right? So everywhere I see x, I write it as x plus h, right? It's going to be square root of x plus h, right, minus the square root of x, and then all over h, right, all over h. So this one, what do I do next? This one, to simplify this one, you need to rationalize the numerator, right? Remember, when you rationalize the denominator, if I've got 1 plus square root of 3 over 1 over, so if I need to rationalize this denominator, it's going to be what? It's going to be multiplied by 1 minus square root of 3 over 1 minus square root of 3, which is the same as multiplying by 1, and multiplying by 1 doesn't change anything, right? So after that, I know that the numerator is going to be 1 minus square root of 3. Then the denominator is going to be 1 plus square root of 3, and then multiplied by 1 minus square root of 3, right? So multiplying the 2 is going to be 1 multiplied by 1. So on top I will keep using this one. And then on the bottom I will have 1 multiplied by 1, which is going to give me 1. And then 1 multiplied by negative square root of x, minus square root of x, minus square root of 3. And then square root of 3 multiplied by 1 is going to be plus square root of 3. And then square root of 3 multiplied by square root of 3 is going to be minus 3, right? So the answer will end up being negative 1 minus square root of 3 over 2, negative 2, right? So that is it, because these two will cancel out, and then 1 minus 3 is 2, right? So there it is. That is what we get when we rationalize that equation, right? So this is what the calculator does. It rationalizes the denominator. Mathematically, we are not supposed to have a denominator which is irrational, right? But in this case, when we are differentiating, right, remember our only problem is the denominator of h, right? So to get rid of the denominator of h, we rationalize the numerator, right? So it's going to be what? It's going to be lim h approaches 0, and then it's going to be what? It's going to be the square root of x plus h, and then minus square root of x, and then over h, and then we're going to multiply it by 1, but 1 was going to be written with the same thing but with different sign here, right? So it's going to be the square root of x plus h, and then plus square root of x all over square root of x plus h plus square root of x. Remember, something on top and the bottom, they are all the same, right? They are all the same. So that's where we start, right? So after this one, we're going to write lim, and then h still approaching 0, and then multiplying the numerator with the numerator. Obviously I will have square root of x plus h minus square root of x multiplied by what? Multiplied by square root of x plus h plus square root of x, right? And then on the denominator, I'm going to have h into square root of x plus h, right? And then plus square root of x, right? I'm just not gonna bring in this the h there, because I feel like my things in the denominator will be mixed up, right? Will be mixed up with h. So when it is outside, I feel like maybe I stand a chance maybe I will be able to factor it out, right? So let's simplify the numerator. The numerator is still lim, and then h approaches 0. So the numerator, I'm going to multiply these two, right? Remember, square root of 3 multiplied by square root of 3 gives us 3, right? Square root of 100 multiplied by square root of 100 will give us 100, right? Square root of the same thing, it gives us that thing, right? Multiplied by the square root of the same thing, it gives us that thing. So the first one is going to give us x plus h, right? It's going to be x plus h, right? And then this one multiplied by the last one there is going to be what? It's going to be square root of x plus h, square root of x, right? It's going to be plus square root of x plus h multiplied by square root of x, right? Multiplied by square root of x, right? And then this one and this one is going to be negative square root of x plus h multiplied by square root of x, square root of x, right? And then square root of x multiplied by square root of x, the negative, the other is negative, the other is positive, so I'm going to have negative. But remember, square root of x and square root of x will give us x, right? So all over h, right? So it's h with what? It's h into x plus h, and then square root of x plus h, and then plus square root of x, right? So that's what we have in the denominator. So remember, you can see that on numerator there, I've got two things that are the same, right? This thing and this thing are the same, right? So when they are the same, the other is negative, the other is positive, it means that they're going to give us 0, right? So what we're going to have now is going to be lim h approaching 0, and then what do we have now? We're going to have x plus h, and then the last x there, right? All over the denominator, which is h into x square root of x plus h plus square root of x, right? So that is what we have as the denominator. So it's going to be lim h approaching 0, and then x minus x is going to be 0, right? So I'm left with h over h into square root of x plus h, and then plus square root of x, right? So the square root of the h and the h will cancel, so I'll be left with lim h is still approaching 0, and then I've got square root of x plus h, right? 1 over square root of x plus h, 1 over square root of x plus h is 1 over square root of x plus h, and then plus the square root of x, right? So after that, my h can approach 0. I will not be dividing by 0, right? So it's going to be equal to 1 over, and then when my square root, my h becomes 0, I will have square root of x plus square root of x, right? So the answer is going to be 1 over 2 square root of x. So that's going to be my answer, right? That's going to be my answer. Remember, what was I differentiating? It was square root of x. So let's see if it's the same, right? So remember, square root of x is the same as x to the power of 1 over 2, right? So that is my f of x is x to the power of 1 over 2. So when I need to differentiate this one, obviously it's going to be f prime of x is equals to 1 over 2 multiplied with 1, so it's going to be 1 over 2 x to the power of 1 over 2 minus 1, so it's the same as 1 over 2 x to the power of negative 1 over 2, right? So this is the same as 1 over 2 x to the power of 1 over 2. So what is x to the power of 1 over 2 is the square root of x, right? So you can see that this answer is correct, right? So we can see that we have proven our answer. Our answer is correct. Our answer is correct. So I hope everyone understands this one. So if you don't, you know what to do. You can just call me and then I will oblige to help you, right? Okay, so let's go to the next question. Let's quickly go to the next question. Let's quickly go to the next question. I wanted to take this video as quickly as possible. Number 5, we are determining the derivative of f using the first principle. F of x is 1 over square root of x, right? So that's going to be f prime of x. So let me use this other color. It's going to be f prime of x. F prime of x is equals to lim h is approaching 0, and then I've got f of x plus h minus f of x all over h, right? So this one's going to be lim h approaching 0, and then it's going to be it's 1 over square root of x, right? So it's 1 over square root of x plus h minus f of x, which is 1 over square root of x, right? All over h, right? So that is how we write our lim, right? Okay, and then after that, the first step is going to be what? The first step is going to be adding the numerator, right? Because you can see that I've got two things I need to make it one, right? So it's going to be what? I need my LCD, right? And then h is approaching 0, so my LCD here is going to be square root of x plus h multiplied by square root of x, right? And then on top, obviously, I'm going to have square root of x multiplied by 1. It's going to be square root of x minus x square root of x plus h multiplied by 1 square root of x plus h all over h, right? So that is my first thing there, right? That's my first thing there. And then after that, this one, remember, this one is the same as over 1, right? So I'm going to do that one, right? So I'm going to because I'm avoiding long fractions, right? It's going to be lim my h is approaching 0, and then I'm going to have square root of x minus square root of x plus h, and then all over the square root of x plus h multiplied by the square root of x, right? And then remember, it's going to be multiplied by 1 h, right? I change this one to be in numerator denominator, so that I change it to multiplication, right? So it's going to be what? It's going to be my lim h approaching 0, and then I've got square root of x minus square root of x plus h, and all over the square root of x plus h, and then square root of x, right? Now remember, the h outside this h will multiply everything down there, right? And then, which means that now I need to rationalize my numerator, right? So I told you that everything with a square root, you will need to rationalize your numerator. So it's going to be what? It's going to be the square root of x plus square root of x plus h all over square root of x plus square root of x plus h, right? So that we can rationalize the numerator, right? So it's going to be lim, and then h equals to 0, and then the numerator obviously is going to be this multiplied by this and this multiplied by this, because the middle terms are going to cancel out like we did in the previous question, right? it's going to be the x, going to be square root of x multiplied by square root of x, which is x, right? And then minus square root of x plus h, so it's going to be minus x plus h, right? X plus h, right? All over what? All over h into the denominator. I'll keep it as it is, so it's x plus h, so x plus h, right? And then it's going to be square root of x, and then it's going to be this thing here, right? Because it's also multiplying. Remember, when we're multiplying numerator, denominator multiplies the denominator, right? So it's going to have square root of x plus the square root of x plus h, right? So there we are. And then it's going to be lim h approaching 0, and then on top I'm going to have x minus x plus h, right? So x minus x there is going to cancel, right? So let me just cancel them. Already, right? Let me just cancel them already by removing them there, right? I'm avoiding to write so many things, right? So it's minus h, not plus h, right? Because the negative is going to get inside, so it's going to be all over. Remember, it's h into square root of x plus h, and then square root of x, and then square root of x plus the square root of x plus h, right? So there we are. So this one and this one will cancel, so we have the h is still approaching 0, and then I've got negative 1 there on top, and then on the denominator I'm going to have square root of x plus h, and then I'm going to have square root of x, and then we're going to have square root of x plus square root of x plus h, right? And then after that, that's when my h can approach 0, because I'm not going to be having 0 at the denominator, right? So I've got lim h approaching 0, and then I'm going to have negative 1 all over. So h will be, this will be 0, and this will be 0, right? So I will be left with square root of x multiplied by square root of x, right? This one and this one, right? And then that other side I'm going to have square root of x plus square root of x, right? So now let's simplify. It's going to be lim, sorry, my h have already approached 0. I'm not supposed to write this lim once my h approached 0, right? So it means that I've got negative 1 all over square root of x multiplied by square root of x is x, right? And then square root of x plus square root of x is 2 square root of x, right? So that's my answer, but let me simplify it, right? So it's negative 1 over 2 x multiplied by square root of x. So square root of x, I'm going to write it as x to the power of 1 over 2, right? X to the power of 1 over 2 is the square root of x, right? So after that, I'm going to add my numerator. So it's going to be negative 1 over 2 x to the power of, this is 1. 1 plus 1 over 2 is 3 over 2, right? So the answer is that one. It's negative 1 over 2 x to the power of 3 over 2. So let's verify that. So this was 1 over square root of x, which can be written as 1 over x to the power of 1 over 2, which is the same as x to the power of negative 1 over 2, right? So that is our f of x, right? So when we derivate f prime of x, it's going to be negative 1 over 2, and then x to the power of negative 1 over 2 minus 1. So the answer is negative 1 over 2 x to the power of negative 3 over 2. So we make it this positive exponent. It's going to be negative 1 over 2 x to the power of 3 over 2. So you can see that our answer is correct, right? So we're verifying our answer, right? So let's go to the last one. Let's look at the last one. The last one is easy. It's a normal one, like the first ones we did, right? Okay, so let's look at it. Let's determine the derivative. The derivative of f using the first principle. If f of x is ax squared plus b, right? So remember, this f prime of x is equals to lim, h approaching 0, and then I've got f of x plus h, and then minus f of x, right? And then all over h. So this one is going to be what? Remember, it's going to be lim h approaching 0, and then for x, I'm going to write x plus h, right? So it's going to be a into x plus h squared plus b minus into ax squared plus b, right? And then all over h, right? So it's going to be lim h will be approaching 0, right? Lim h will be approaching 0, and then it's going to be what? It's going to be a into x squared plus 2hx plus h squared minus plus b minus ax squared minus b, right? And then remember, I'll take a inside the brackets there, right? So it's going to be lim h is still approaching 0, so it's going to be ax squared plus 2ahx, and then plus ah squared plus b minus ax squared minus b all over h, right? And then now it means that this one and this one are our like terms, and then the b plus b and negative b are also our like terms, so they're going to give us 0 because the other is positive and the other is negative, right? So I have lim h approaching 0, and then I will have 2ahx plus ah squared all over h, right? So it's going to be lim, and then our h is approaching 0, and then we factor out h on top. We have ax, we have 2ax, remember it's 2 there, 2ax plus ah all over h. So the h and the h will cancel. We'll be left with what? With lim h approaching 0, and then it's going to be a 2ax plus ah, right? Now my h can approach 0, so I'll have 2ax, and then that one will be 0. So that is my answer. So let's look at the equation again. It was ax squared. It was f of x equals to ax squared minus b. So remember, b and a are constants, right? So we're going to have 2ax minus 0. So we can just leave it like this. So yes, our answer is correct. The answer is 2ax, right? So we are done with our question paper.